Hello students, welcome to classroom. So today is the day that we will be trying the numericals together. So let us try this numerical together. This numerical is taken from your page 144, example 9.1. So without any delay, let us try to solve this together. So first let us read the question. A convex mirror used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. Now the first rule to solving a numerical is to read the question, okay? Is to understand the question. So how do you understand the question? The way to understand the question is to read the question again and again. So if you ask me, I would like you to read the question twice, thrice, okay? Until you get an idea. By reading the question again and again, you get more idea on what the question is asking you. Initially you may not, but then if you read it twice, thrice, you'll get some more ideas, okay? So we have read the question. Now on reading the question, the first thing that I should look is what type of mirror. Okay, these are numerical problems based on mirrors, okay? So we are doing numerical problems based on mirror because in the previous video we have learned about mirror formula, magnification. So the time has come where we have to apply those formulas that we have learned into application. So let us use the formulas that we have learned and solve this question. Okay, this is not very difficult, this is very easy. Okay, I assure you that you will be able to solve numericals problems based on mirrors, okay, easily. Okay, all you need to do is like know the formula and understand the question. So that way it's very easy. Okay, so I was saying the first thing that you should look out while trying to solve a numerical question is to identify what type of mirror it is. There are only two types of mirror. We have the concave, okay, concave and the convex. Okay, so the question clearly mentions here what type of mirror it is. It is a convex mirror. So my attention goes here. So this word convex confirms that, okay, this is a convex mirror. So now what I do is on the rough, okay, because on numerical problems it will be good if you associate with a ray diagram. So let's draw the ray diagram for this very question. Okay, every numerical question will have a ray diagram. Okay, so you should know how to draw the ray diagram for each question. Okay, so let us try to draw the numerical diagram, the ray diagram for this question. So it's a convex mirror. So let us draw a convex mirror. How will I draw a convex mirror? The convex mirror, the reflecting surface is the protruding part. So let us draw a convex mirror here, like this. Okay, so this is the back side. Always mark the back side. The reflecting side is this side. Okay, the left side is the reflecting side. Remember class, the left side is the reflecting side. So this side is the reflecting side. Okay, so now I will draw the principal axis. Remember, this is a convex mirror, so I will be drawing the the principal axis, okay, on the back side. The principal axis will be drawn here also because convex mirror gives us a virtual image. Virtual images are formed, okay, at the back of the mirror. Okay, the left side is called the front of the mirror. This is called the back of the mirror. So I will be extending the principal axis till the back of the mirror. So let us draw the principal axis like this. Extend it till the end. Okay, so this is what is this class? This is the famous pole. Okay, all measurements start from the pole. Do not forget this. Okay, that will be very useful here. All measurements start from the pole. All right, now let's continue. So solution. So the first thing is to write given. Okay, what things are given to us? Let us write. So okay, now if you have read the question, now while solving numerical problems on mirror and lenses, okay, always focus on what you are asked to find. Okay, so I will suggest you to focus on what the question wants you to find. Okay, in most of the cases the question will tell you to find the image position. So in this question, what are we told to find? Find the position, nature and size of the image C. So image. Okay, so most of the questions will tell you to find the image. There are some questions, of course, where we will be finding the object, but then most of the questions they will tell us to find the image. Okay, so this question is telling us to find the position of the image. So now in the rough, let's go and remember the mirror formula. The mirror formula looks like 1 by V. Okay, so plus 1 by u is equal to 1 by f. Okay, I hope it is visible. So 1 by v plus 1 by u equal to 1 by f. Now here v is image, this is image, you already know that this is image, position. U stands for object, this is object, okay, and this is focal length. Okay, this is focal length, this is focal length, this is focal length. Let's write focal length. Okay, so v is image, the symbol for v is the symbol for image is v, the symbol for object is u, and small letter f is the representation for focal length. Okay, so we have to find v because we are supposed to find the position of the image. Position of the image is represented by v, so we have to find v. So v is what we are supposed to find. Okay, got it? We are supposed to find v. Now that means the other two things should be given to us. So u should be given to us, u is object distance, it should be given to us, and focal length should also be given to us. Okay, so of the three things, one is missing, the other two should be given to us. Okay, it is only when the other two is given to us we will be able to find the missing term, isn't it? So we are finding v, so u and f should be definitely given to us. Let us check whether it is given to us or not. So given, if you read the question, my attention goes to this number. Okay, now you have to pay attention to numbers like this. Okay, pay attention to, your eye should go to numbers. Okay, numbers like 1 2 3 4 5. Okay, so pay attention to numbers like this. So I see 1 here, and again I see 1 here. Let us try to find out what they are. So if I read the question, a convex mirror used for rear view on an automobile has a radius of curvature. So this 3 meter is radius of curvature. So this is radius of curvature. So radius of curvature r. Radius of curvature is represented by r. Okay, so r. So r is given to us 3.00 meter. Class, remember that 3.00 meter is just 3. Okay, 3 meter. Okay, it's exactly the same as your teacher giving, suppose you scored 15 or suppose you scored 9. Okay, then your teacher may write 9.0. 9.0 is 9. All right, so it's the same thing. So 3.00 is 3 only. Okay, remember that. So r is given to us, and then we have then the next information. Let us find out what this information is about. So now from here we are done till here. If a bus is located at 5 meter, so from this mirror, so there is a bus which is at a distance of 5 meter from this mirror. So let us go to the ray diagram. So this is the mirror. So there is a bus which is located at a distance of 5 meter from this mirror. So let's say this is the bus. So this will become the object. So the bus here is the object. Okay, now the bus has to be the object. Why? Because it cannot be the image, is it not? Image. Okay, image we are supposed to find. Okay, then focal length. Focal length I did not tell you, but then from r we can find focal length. So very soon we'll come to it. Okay, so this 5 meter has to be the object because focal length will get it from r, and image we are supposed to find. So left is u. So u has to be this information. So object distance is 5 meter. All right. So object distance is 5 meter. So let us just write here. U is equal to how much? 5. It's given 5.00 meter. 5.00 meter is 5 meter. All right. Now let us find f. Okay. So because see, the mirror formula doesn't have r in it. Okay, it has f in it. So we have to find f. So using this r again, we know the formula of r is not. R is equal to 2f. Okay, so r is equal to 2f. So r value you put, r value is 3. Okay, and 2 into f. So what we will do is we will keep f. F is already in the right hand side. Okay, I'm saying with respect to this equality sign. Okay, this side is my right side, this side is my left side. So my right side, my left side. Okay, so f is already in the right side, keep him there. Okay, don't move him. Now 3 is already in the right side, on my left side, keep him there. Okay, now these two should move. Okay, since the relationship between f and 2 is multiplication, 2 will go below 3. All right, so division of this will give you f. So if we divide this, if 3 is divided by 2, then we get 2 ones are 2, which is 1.0. 2 5s are 10. So we get the value of f to be, now you just write f like this and write 1.5 meters. Okay, so see, we have our focal length. Okay, we have our object distance, and we will be finding the image distance. All right, simple, isn't it? Now after you are done here, always remember to check for the sign now. All right, so let's check for the sign. So because in the previous video, okay, we have learned about sign Cartesian. Okay, very important, we have to check the sign. Now to check the sign, remember to check the sign, remember this, that direction of light is very important. Always, this is the direction of light. Direction of light, very important. Always remember the direction of light. And another very important thing here to remember is pole, because all measurements start from pole. So pole is very important. So now, yes, remember, let's first find the sign for U. I told you earlier, okay, that object distance will always be minus. Object distance will always be minus. So you can straight away go and write here minus, okay, just write here minus 5 meters. Okay, let's check, should it be minus? Now see, where will the object be? The object will be definitely here, isn't it? The object is always kept in front of the mirror. So from here till here will be taken as object distance. Okay, will be taken as object distance. Now measurement will be done from here, because all measurements start from the pole. So we are here, we have to walk in this direction. Okay, to measure this point we have to walk in this direction. So you will be walking in this direction, okay, towards me. Okay, you are walking from pole towards me, whereas light is going, okay, from left to right. The direction of light is, okay, opposite to our walking. You are walking from P to this point. Light is going from this point to this point. So check your direction and the direction of light. Are you moving along the direction of light, or are you moving opposite to the direction of light? You are moving opposite to the direction of light, isn't it? So whenever we move opposite to the direction of light, we get negative value. So U will be minus. Okay, so always minus. Okay, universally minus. So you can always, you have to always write minus. Okay, because object is always kept in front of the mirror. So every time you measure object distance, you will be getting minus. Okay, so minus 5. Then focal length. Now focal length. Now this is the tricky part. So focal length. Now focal length, focus is always taken for the image side. Okay, so whichever side image is from, that focus will be using. Now this is a convex mirror. How many cases are there in convex? 2 cases are there in convex mirror. Okay, now one very important thing I'll tell you. Out of the 2 cases, the first case, it is very rare to have a question on first case. Okay, so you can rule it out. So you can rule it out that there is less chances that there will be a question on first case. Very rarely, but I don't think there's even a question on first case in your textbook. So you can just rule it out. So then you are left with the second case. So out of the 2 cases, there will be no question from the first case. So your questions on convex mirror will always be on the second case. So you know that tells you how important the second case is. So learn properly the second case, because all the questions on convex mirror will be on the second case. All right, so the second case becomes very important. And this question, this ray diagram is also based on second case only. This question itself is based on the second case. All right, so the image will be formed here. We know now that convex mirror gives us a virtual erect images. All virtual images are erect, so we are going to get ourselves an image like this. Okay, so the focus will be considered on the right hand side. We'll be considering the focus on this side. Okay, on this side. So this will be the focus. Okay, no, the focus will be here somewhere. So the reflected ray will pass through the focus, and the image is formed between F and P. I know this because I know clearly the second case. Okay, you will also be able to do that. So the image is formed between F and P. This will be F. Okay, so this focus is considered. We will be considering this focus. So let's measure this focus. So we are considering this focus. So all measurements are from the pole. So to measure this focus, you will be moving like this. Okay, you will be moving from P to F. Your direction of movement is like this, away from me. You are moving away from me. Light is also moving away from me. You are also moving away from me. Both the direction of light and your direction, are you moving along or opposite? You are moving along, isn't it? So whenever your movement correlates with the direction of light, that means when your movement and the direction of light, when both of you are moving in the same direction, you get a positive value. So F will be positive. So F value here is positive. So let me just erase this one. Okay, plus 1.5 meter. I hope you are all following. All right, so we are going slowly, okay, because I want you to know. Okay, now we are done with the sign Cartesian. Now time for us to use the mirror formula. So you write using mirror formula, using mirror formula. If I'm writing very small, okay, if it is not visible, you will have to watch it in HD, okay, 720 pixel or 100, so that way it will be clearer. Okay, so using mirror formula, now write a mirror formula. 1 by v plus 1 by u is equal to 1 by f. Okay, so 1 by v will be 1 by v. We don't know this value. We are actually finding this value, plus, then let's fill up the value. So u value is -5, so -5. Okay, so plus and minus cannot be together, so let's put them inside the bracket, equal to 1 by f. F value is how much? F value is plus 1.5. We don't write plus, so it's just 1.5. all right, now the next thing is I will just take care of these two. I will sort out what sign we will have. Plus into minus, what is the value? Minus. So 1 by v plus into minus, minus 1 by 5 is equal to, now this denominator has got 1.5. I want to remove the decimal. So if the denominator brings a decimal, how do we remove the decimal? Okay, I can remove the decimal by giving a 0. Okay, how many zeros should I give it to the numerator? Since the decimal is in the denominator, the 0 will be received by the numerator. If the decimal happens to be in the numerator, the denominator receives a 0. In our case, the denominator has the decimal, so the numerator will receive the 0. So after the decimal one number, so the numerator will receive 10. 10 means 10. Okay, 10 means 10. So it will be 1 into 10. And then here now without the decimal it's 15. Okay, so one more time, 1 by v minus 1 by 5. I'm going step by step. This is 10 by 15. Okay, some of you who know, you can jump steps like that, but then I'm just going slowly, step by step, so that all of you will be able to follow. So I think I can write one more line. So 1 by v, now 1 by v, the variable this side and all the numbers that side, okay, on the other side. So we'll keep 1 by v on the left side. This is my left side, and this side is my right side. My left and right side I'm determining with respect to this sign of equality. Okay, with respect to the sign of equality, this is left side. With respect to this is right side. Okay, so this is left side, that side is right side. We will send this minus 1 by 5 to that side. All the numbers will be sent to that side. So this sign will be written here now, and whoever was there from before, you write him who was there. It's like this only. This goes there, becomes plus, so 1 by 5. Okay, many students still make mistake in these kind of things. Okay, so you have to learn this. Okay, it's just that whenever a number shifts from its original place and goes to the other side means crossing this sign of equality, their sign gets changed, not their value. Okay, so 1 by 5 will still be 1 by 5, but the sign will change. Okay, so I hope you followed. Now let's continue. So now let's continue again. I'll draw an arrow here. Okay, let's continue. Yeah, let's continue from here. Okay, all right, so let's continue this one. Now what do I do now? I have to take LCM. So yes, I need more space, so I'll use this one. So 1 by v is equal to, now LCM, we have to take LCM. LCM is taken for the denominators, so 15 and 5 LCM. What we will get? We'll get 15. Okay, now if there is anyone who is not able to take LCM, see, LCM you always take for the denominators. Let me show you in the graph. So the denominators are 15 and 5. Okay, LCM means least common multiple. So you have to opt for the least number, means the smallest number. Okay, so both the numbers are 5 and 15. The smallest possible factor here is 5, so take 5 here. So 5 3's are 15, 5 1's are 5. Then 3 1's are 3. Already 1 was before 1. So these two you have to multiply. This is 5 into 3. 5 into 3 is 15. So the LCM will be 15. Alright. Then what number will be here? Okay, the sign will be plus. Remember, the sign will be plus. All you have to do is sort out what numbers to come here. Okay, so here it will be 10. Here it will be 10. Okay, here it will be 10. and this side, what number will it be? Okay, what number will it be? It will be 5. How many times are 15? 5 denominator with denominator. 5 how many times are 15? 5 into 3, is not? So 5 times 3. Okay, 5 times 3, 5 times 3, 5 times 3. This denominator 5 times 3 gives you 15. Okay, so this 3 will multiply with the number at the numerator. So 3 times 1 gives you how much? 3, nah? So that's how it is done. So 1 by V is equal to 10 plus 3 is 13 by 15. What you will do? Cross multiplication. Go for cross multiplication. Okay. In exam, don't write this with pen. You can do this by pencil. This arrow, this X mark, you can do with pencil. Don't do with pen. Then what you will do? We'll first multiply V with 13. So V into 13, and this is 15 into 1, which will be 15. Okay. 15 into 1 is 15. Anything multiplied with 1 is the number itself. So what we will do is, this is 13V, and this is 15. Now what I have to do is, I need the value for V. 13 is with V, so I have to remove 13. So let's remove 13. So we have to send 13 to this side again. Okay, but the relationship between V and 13 is multiplication. There is multiplication here, na? So when it is multiplication, this number goes below 15. Okay, so this is V is equal to 15 by 13. So we have to divide this. So let's divide this. So we have to divide this now. Let's divide it. Okay, I'll erase this now though. Okay, I'm going to erase this. I will erase this now. So 13 divides 15. So this will be 13 times 1. 13 times 1, 13. 14, 15, 2. Point. Okay, because there is no number, is not? So point. After giving point, you get 1, 0. So this will be 13 ones are 13 only. 13 ones are 13. So this becomes 10. 10 minus 3, 7. Point is already there, so you get 1 more 0. So 13 times how much is 70? 13, 5, no. So 13, 5 is 75, I guess. 3, 5, 15. Yes, so it will be 4. So 13 times 4. 4 3s are 12. 1 in hand, 4 1s are 4. 4 3s are 12. 1 in hand, 4 1s are 4, 5, 52. So 52. Okay. 4. With 13 into 5, how much? 5 3s are 15. 1 in hand, 5 1s are 5, 6. Oh, I should go for... Why am I going for 4? I should go for 5. 3 5 is 15, 1 in hand, 3 5 is 15, 1 in hand, 5 on the 5, 6 65. I can go for 5. Then this is 5. Then this is 0. Then this will be only this bigger, so it will be 13 into 3. 3 is a 9. 3 1s are 3. 39. So I should go for this one. So 39. Okay, no need to get this answer. We need these numbers only. Alright, so it's 1.153. Okay, 1.153. Look here, class. 1.153. After the decimal, you have written 3 numbers. After the decimal, you have written 3 numbers. 1, 5, 3. Okay, we need after the decimal maximum, we go for 2 digits only. Okay, so 1 point, we go for 2 digits. Okay, since we're going for 2 digits, now see here, that means the number has to be only these 2. Okay, so it will be 1 and 5. Now see, this third number is actually useful. Okay, this third number we found to check whether 5 will be rounded or not. So what is round off? See, if now the actual number is 1.53, if suppose this number instead of 3, if it was 7, then what will happen? Okay, what will happen? Now see, we're only going to write 2 numbers after the decimal, isn't it? That means we will be writing only two numbers here. So now the third number happens to be 7. 7 is bigger than 5. Any number bigger than, if the third number happens to be bigger than 5 or equal to 5, then the second number gets plus 1. So the answer will not be 1.5, but it will be 5 plus 1, which will be 6. Alright, got it? It will be like this. But our original number was 1.153. And we are supposed to write, we are going to write only 2 places after decimal. So the third number, we will check, is this bigger than 5 or less than 5? This is smaller than 5. That means this will not contribute to rounding off to 5. So 5 will remain as it is. So it will be 1, 5. Okay. So the final answer is 1.15. Don't forget the unit, which is meters. Alright. Now, this is the answer of V. We have found the position of the image. Okay, we have found the position of the image. the position of the image is 1.5 meter. That means the image is at a distance of 1.5 meter. So if this is the image, then the distance from the pole to the image is 1.5 meters. All right, the object distance was how much? 5.00 meters, isn't it? Early. Now we are done with the image. Now we have to find the size, nature and the size. Well, this is convex mirrors. Convex mirrors, the nature is virtual and erect. So you can just write here nature. You write nature is equal to virtual and erect. This will do, because convex mirrors gives us a virtual and an erect case. Okay, the image is above the principal axis. Okay, so it is erect. And one more thing, in the previous video we have discussed the sign convention for the size also, isn't it? For the height also, anything standing above the principal axis, their heights will be taken as positive. Okay, so the height of the object is always positive because the object will always be standing upright on the principal axis. The image, on the other hand, if it is a real image, it will be formed below the principal axis like this. But virtual images, you can see they are standing upright. So the image height will also be the image height will also be plus. So are we getting plus? What sign do you see here? You see a positive sign, isn't it? You don't see any negative, that means it is positive. So it is correct. Okay, the height is positive, okay, which is indicated by the answer that we got. So the answer is correct. Okay, and it justifies this case also. It's a virtual case, so the height should be positive. Okay, virtual and erect. All erect images should have a positive size. Okay, positive height. Height of the image is represented by hi. Okay, and height of the object ho. Now we are done with the position. We are done with the nature. Now we have to deal with the size. So let's find the size. Now there is one formula to find the size, which is m is equal to hi by ho. Usually this is the default formula for finding the size. Okay, because hi means the size or the height of the image, and ho means the height of the object. But to use this formula, the question has to give us ho. To use this formula, the question has to provide us with the height of the object. Did the question provide us with the height of the object? No. The only information the question provided us was the radius of curvature and the object distance. So we cannot be using this formula. Alright, those students who are having confusion, let me clarify this, that you cannot be using this formula because of lack of information. We don't have ho, and this formula is actually this is more easy. With this formula it will be very easy, but we need ho, which the question did not provide for this question. So for this question, this formula will not be useful, so we won't be using this. Okay, so we'll be finding size in a different way. We'll be finding size using magnification, because from magnification also we can find the size. Okay, we can get an idea of the size. So directly hi by ho formula may not be useful here. We may not be able to use it, but from magnification we can find size also. So let us try to find size using magnification. So let's go for magnification now. So to find size, we are going to find size. Okay, now we'll find size. So let's find size. So size. To find size, I will be using the formula of m. M formula is minus negative of image distance by u. Okay, so see, I have both the values of v and u. Okay, that's why I'm going for I'm using the formula. Okay, I have v value and I have u value also. So this formula can help me find the size. So I'm opting for this one, not the other one. Okay, so minus from the formula v value is how much? 1.15. So 1.15. Downside you have minus, because object is always minus, you have 5. Okay, minus gets cancelled. You are left with 1.15 by 5. So remove the decimal. Now the decimal is in the numerator, so the denominator will receive the zeros. So let's remove the decimals. So 115, and denominator will get 2 zeros, which is 100. So you can cut this. Okay, we can cut this one. 5 ones are 5, 5 2s are 10, 11 1 in hand, 5 3s are 15. So you are left with 23 by 100. 1 into 100 is 100. So now we have to divide this. Well, since the denominator is 100, we don't need to divide. Okay, if for this kind of question, for this kind of division, we just can write the point. So there are 2 zeros in the denominator, so the decimal will be, okay, the decimal will be after 2 numbers, so 2 digits, and there will be a point here. Okay, so 3 will be here, 2 will be here, and 0 will be here. Okay, got it? If this is confusing for you, then you have to go the long method. So you have to divide the 100, divide 23. Okay, so 2 less. This is 3 number, these 2 numbers cannot divide. 23 needs help, so put point, he gets 230. So 100, 2 is 200. Okay, then this is 0. 3 minus 0 is 3. 2 minus 2 is 0. Only the point taken, so again 0 he gets 0. 103 is 300. And that's how you do. Okay, so if you are still getting confused, you have to use this formula, this technique, or actually this is easy. So I will encourage you to follow this method, okay, by putting decimal by depending on the number of zeros. Okay, so 2 zeros I see, so the point will be after 2 numbers. Okay, before 2 numbers, sorry, before 2 numbers, so the point will come here. We are counting from left side. Okay, every time we count from the left side, we always count from the side. So 1, 2, decimal will be after 2 numbers, so here, okay, before 2, in front of 2. Okay, and then decimal should always be covered, so it will be 0. Don't ever write 0.23 as the answer. This is wrong. Put 0. Okay, okay, we never expose point. Okay, it should be covered by 0. So the answer is 0.23. Okay, so the answer is 0.23. I hope you all got it. Let me erase this now. So let me erase this also. Now, so the size is 0.23. Now what is the meaning of this? So see here. Yes. So what answer did we get? We got the answer of magnification, isn't it? M equal to 0.23. Now, remember in the previous video we were discussing m equal to, we have m equal to 1, we have m equal to less than 1, and we have m equal to greater than 1. This tree becomes very important. Now let me explain to you one by one again. So if m is equal to 1, what do you mean by m equal to 1? If m is equal to 1, that means object height and the image height are same. Okay, so if this is the object, this is the image. Actually they're almost same. Okay, they're almost same. So make it same. Let me use another marker here. So let me use this one. Okay, they're of the same company. So if m is equal to 1, we are discussing about this one, class, this one. What do you mean by m equal to 1? If m is equal to 1, that means they are talking about this. Let the black one be the object and let the red one be the image. So if m is equal to 1, if magnification is equal to 1, that means size of the object is equal to the size of the image. That means this is the case. Okay, see, they are of the same height. Nah? They have the same height. This is when m is equal to 1. Okay, now what if m is greater than 1? If magnification is greater than 1, if magnification is greater than 1, that means this was the object, isn't it? This is the image. If magnification is greater than 1, that means the image is taller. So the image is taller. That means this is the case. Okay, this is the case. Object, the size of the object and the size of the image. See, which is taller? Whose size is larger? Image size is larger, isn't it? This is what happens when m is greater than 1. So magnification greater than 1, magnification greater than 1, this is the story. Okay, magnification greater than 1, this is how it looks like. Image is larger than the object. Okay, then if m is less than 1, if m is less than 1, what does it mean? M less than 1, magnification is less than 1. If magnification is less than 1, the story will be somewhat like this. Okay, remember this is the object. I am not changing the object. Now the image is here. This is what magnification less than 1 means. Okay, magnification less than 1 means the image is smaller, the object is taller. Okay, so here, okay, this is what magnification less than 1 means. I hope you understood. Okay, so we are getting m equal to 0.23. So where are we? Are we in the first case or the second case or the third case? Now 0.23 is less than 1. That means we are in the third case. We are in the first case. Magnification less than 1. Okay, magnification is less than 1. Okay, the answer of magnification is 0.23. 0.23 is less than 1, so we are in this category. Okay, so we are in this category. That means we are here. Okay, we are here. Magnification is less than 1. This is less than 1, is not less than 1. Okay, so we are in this category. So how to interpret this answer then? M equal to 0.23. How to interpret this? See, to interpret this is interpreted like that. So this means that the image, okay, the image is smaller than the object by a factor of 0.23. I repeat, how do we interpret this value? How do we interpret this answer? M equal to 0.23. We interpret this information like this, that the image is smaller to the object by a factor of 0.23. You still don't understand. Okay, let me use a simple example. Suppose your height is 7 feet. 7 feet. Quite tall, is not? You're very tall. 7 feet. And your friend is 5 feet. Okay. So both of you are standing like this. Okay. So this is you. And this is your friend. So you are taller than your friend. Okay, you are taller than your friend. It's visibly clear that you are taller than your friend. Okay. Now the question is, by how much are you taller than your friend? So what is the answer? You are 7 feet. You are 7 foot. Your friend is 5 foot. So by how much you are taller than your friend? You are taller than your friend by a factor of 2, is it not? The answer is 2, nah? Is it not? Now let me reverse the question. By what factor is your friend shorter than you? The answer is still 2. Okay, exactly same. You have to bring the relation here. You have to correlate the same thing. M equal to 0.23 means that the image is shorter. The image is shorter, okay, compared to the object by a factor of 0.23. That means this becomes this answer. Okay, this becomes this answer. So it's like me asking you that your friend is shorter to you by a factor of 2. In the same way, M equal to 0.23 means the image, which is your friend, is shorter to the image is shorter to the object. Your friend is shorter than you by a factor of 2 in your friend's case. In this case, by a factor of 0.23. I hope I am clear now. I hope all of you understood. Okay, so this is it. Okay, so this is how we interpret this. Now the value of this is plus. It's a positive value. Okay, indicating that the image is upright. Okay, image upright. Okay, positive magnification. The sign is plus. Okay, so indicating that the image is upright. All right, so that's it. This is what we are supposed to find. We have found the position, nature, and the size of the image. So the size of the image is this one. So finally you will write, therefore the image is smaller in size. The image is smaller in size by a factor of 0.23. Okay, so this is it. The example 9.1 numerical will be solved like this. All right, so I hope it is clear. Okay, you can rewind the video again and then revisit those points which is confusing for you, and I assure you that you will understand. So thank you once again, and then I will see you again in the next video. Until then, God bless you, stay tuned and stay healthy.